Hello, and welcome to another tutorial. This time, we're going to be taking a look at, not hexOS, we're going to be taking a look at the harder variant known as octOS. Now, octOS is a non-canon addition to hexOS that's very hard and very tedious. It's very similar to hexOS in that you have to look at a sequence that's playing along with some notes to get some numbers and some information, use that to modify the numbers up here, and then submit a 3-digit number. Be aware that if you play this, aka just tap the module once, you will not be able to go into octOS just because. So once you have pressed the module, you can't enter octOS. To enter it, you simply have to submit 888. And the way you submit numbers onto this module is when the first digit, second digit, or third digit is the number you want to submit. So since I want to submit the first number as an 8, when the first number is an 8, I'll hold and release. Let's say I just submit 1, and that's wrong. If I want to delete my input, I just simply submit the empty one. If I'm in the middle of submitting and I go, hey, I don't need that number, you just keep holding it and it'll cancel your input. So if you ever hold on a wrong one, just keep holding and it'll stop your submission and you can try again. So to enter octOS, you simply have to submit 8 when the first is an 8, then the second, then the third. And there we have it. Goon module initiated. Now, I'll just let you take in how it looks and sounds.
Emergency cleared. All personnel, please return to your stations.
From this information, we'll be getting 2 of these sequences in here, which will give us 2 numbers. We will have decoded up to 6 letters from here, which will give us a key, which we'll use later. That information we'll be using here to get a bunch of other information, a bunch of dumb stuff, to be able to modify the numbers up here in order to get our 3-digit number, which we must submit into the module. Now, let's just begin. I usually start with the first one, rhythm identification, which is the sequence that's playing. So let's just go. Before I start, I will say that if you look down here, there is 1 dot, 2 dots, 3 dots, 1 colon, 2 colon, 3 colons. Normally in hexOS there's 2 sequences, but they don't matter. Here they do matter. You want the first one first and the second one second. So this is stage 1 because there's 1 note or 1 dot for every 1 stage, and here there's 2 notes for every 1 stage. I'll explain why there appears 1, 2, and 3 later, because that's on the perfect cipher on the next page. But yeah, so this is stage 1, or sequence 1, and this is sequence 2. I'll be starting with sequence 1. I can already say it's most likely one of these. Maybe this one. This is because, actually let me just highlight these. This is because you hear that first beat, and then you hear a long, or not a long pause, but a decently sized pause, before hearing a note again. Let's try it. Just from listening again, I think it's one of these 2. This is because I hear an explosion of 5 notes immediately after. Let's try it again. I hear note, note, and then 5 notes, and then a bunch of other random. Listen closely. I hear the first explosion, a bunch of medium notes, and then a short one, followed by a few notes, short one, followed by a short one, followed by a big explosion of notes. Try listening to that. So, you're going to be listening for the group of 5 notes, then a little bit of wait time of notes, and then a quick 3 note, space, 3 note small, and then a large one again at the end. Yes, that's what I hear. So the first sequence is 20, because that's the number we get over here. Refresh the page. Now we want the second sequence. This has the same of being a long one, so I can already move all of these. Okay, so there were no explosions, as I like to call them, until the very end. So I get 0, 1, because it's the only one that just has a bunch of notes and then an explosion at the end. I'll let you listen to it again so you can see it for yourself. Yeah, 0, 1. So these are our two numbers. We'll concatenate them together so we get 2, 0, 0, 1. We'll be using this number later. For now, we just leave it up here. Now we want to move down to the... I think it's a much harder, this one. Because, like I was going to explain later, there's different things on here. And every time there's another 1 or 2 dots that appear, if you look closely, the symbols might change. This is because there's 6 sequences in all, 3 subsequences for each one. I like to call these 1.1, 1.2, 1.3, 2.1, 2.2, and 2.3. So this indicates the sequence 1, subsequence 1, sequence 1, subsequence 2. So this is when there's 1 dot, which is what I'd call full stops, 1 full stop, 2 full stop, 3 full stops. This one is on the second sequence, so this would be 1 colon, 2 colon, 3 colon. So here, 1 full stop, 2 full stop, 3 full stop. And now again, 1 colon, 2 colon, 3 colon. And all that information goes at once. So we have to decode 6 letters. We don't have to decode 6 letters, we just have to decode enough to deduce what this is. So sometimes, let's say we get a TH. But let's just say our first 2 are TH. Let's say we have this and this. You see that these are different, except there's a lot of times where there's an E followed. So, if we were to decode the next letter, the E, there'd be a good chance we would basically get no information out of it. So we could basically skip that and check what the character right after it was. Because here, if we check the character right after, we'd get an E, which not many have. If we do space E, I mean, that is kind of unfair. I should be using regex, but it's to prove a point. Find the letter that would eliminate as many ones as possible. Don't just look for the first one, second one, third one, and so on. Do the one that gives you the most information, so you don't have to do as much work. Because there's a lot of work to be done elsewhere. Alright. First step is to finding the symbols that shows during the first one. That is the cross here. Let me hide that in blue. The grid with the filled in. And the one with the corners touching elsewhere. Good. These will be important once we've decoded the character, because the character has actually been encoded. So let's say that we get the colors. I'll explain what getting the colors actually means a little bit later. But let's say we get white, black, black. Let's just say that. We look at the first row, we find the whites, okay, that's those ones. Then we look at the next one, which is black, and we look at the next one, black. That's an A. So white, black, black would be an A. And let's say we got an A with these exact symbols. We'd move 4 left, 1, 2, 3, 4, then another 2 left, 1, 2, and then another 1 left, which would be an R. You could also just sum them up, this is just to prove a point. You take all of them, add the lefts and right together, and go that amount left or right, and then you get your new letter. this letter will be the one appearing in here. The decrypted letter, as you could call it. Alright. I think we should just get into it and start dribbling. Okay. So, if you notice, each of these symbols have two colors that are present. The one you need to find is the one missing. So in this case, in all of the symbols you see on the manual, the one that's missing is white. So if you see one that's magenta and black, the true color is white. So you need to look at the one that's missing most of the time, the one that's least there. And you're going to be doing this from left, middle, and right, respectively. Left being the first character, or the first thing, the white in this case. Middle being the middle character, and right being the rightmost character. So, let's start doing that. Oh, my mouth is really dry. Okay, so that might be magenta. When I look at the first character here, I see magenta only twice, I think. Yes, I see magenta only twice, or 3 times. It's the one that's missing most that you want to find. You could write these up if you're on Twitch Plays. You can slow it down and you can write it in each individual color that's missing, and then you can just find the one there's most occurrences. Because there's like 7 or 8 flashes. So let's say we have black, magenta, white, white, black, black, white, magenta, white. That would be a little dumb. Let's say it's this. Let's say it's a sequence. So here we could see, okay, there's only 2 blacks, so it's definitely not black. And oh, there's only 2 whites, it's definitely not white, because there's most magentas. You want to find the one that's missing the most. You can't really do that here because it's going so fast, you can't even note it down. So, now I'm going to look again for the left one. Yeah, I'm certain it's magenta. Now I'm going to look for the middle one. Maybe magenta again, I need to be sure. Let's see. Yeah, I think that's magenta. Okay. So now we're gonna get the last one. I think that one was also magenta. Let me look again. Definitely magenta. So just looking at it at the start, I get magenta, magenta, magenta. There's a good chance that one of these colors is wrong. So once you have the letters, don't immediately assume that they're correct, because they're most likely not. So yeah, so 7 left. 1, 2, 3, 4, 5, 6, 7 left from Sulu is a kilo. Because we look at the symbols, okay, we have this one playing at the first sequence, this one playing at the first sequence, and this one playing at the first sequence. And we're gonna go 1, 2, 4 left. Add them together, that's 7. So 1, 2, 3, 4, 5, 6, 7. Kilo. And then look at the second one. This one's gonna be the hardest one because it's in the middle of a sequence. We're gonna start by getting the new symbols. The corners and the down arrow filled. And the up arrow is not filled. Corners, that. Yep, that's correct. Okay. Now we look at the first one. Did not see a lot of white. Let me check that again. Yeah, I see white like twice. Let me look at the middle. I think this one is black? Let me just make sure. Yeah, black does not. It appears like only twice there as well. Then I'm gonna look at the last one. Think that's a white. I need to confirm that though. I'm not entirely sure. It's definitely white, definitely white. White, black, white is a Juliet. When we move it 6 left, 3 right, and 1 left, that gives us 4 left. We move 1, 2, 3, 4, we get an F. And you see KF, there's no one being KF. I'm clearly gonna check the first one again because... Or no, I'm not. I'm not gonna start double checking. It's better to get more letters than to try and correct the letters that might both be wrong. I'm gonna get the third one. Let's figure out what unique symbols they have. Square, grid, and this weird one. Square, grid, weird one. Yep. Let's see. I did not see a lot of white. Let me check that again. Yep, only appeared twice. Didn't see a lot of white on the middle one as well. Let me check that one. Yep, I think that's white appeared like 3 times. Then the last one. I think that's also a white. Let me quickly check that. Definitely a white. White, white, white is Mike. And then we want to go 14 right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is a space. I am gonna check the first one again because... Yeah. I mean... No, I'm not gonna check the first one because there's a high chance that it's an I or an O. And if it's an O, I still have to get one more letter. But I see that there's not a single one of the letters after the space that's the same. You see there's an O, there's a U, there's an I, there's an M. So if we can get the next letter, then we already have what we need. So I'm not even going to bother. Let me refresh the page. So I'm going to look at the second one first. Weird one, up arrow filled, or not filled, I mean. Completely missed them all there. Up and down arrow not filled. Why do I have to move 16 right? Please, do not do that. Okay. So, I'm gonna just get the first one. I think that's a magenta. Definitely a magenta. Middle one. Ooh, I am not sure. Black? I think that's a black. Yeah, that's a black. Then looking at the last one, I'm 99% sure that's a black. I'm going to click on check again. Definitely a black. Magenta, black, black. That is a blue. Not blue, that's a Bravo. This is the color. Blue, you're gonna move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's an O. Wouldn't you look at that? I'm probably gonna look at the first one again because I want to see if it's close. Just because. You know. I want to... Better safe than sorry. Better safe than sorry is what I'm trying to say. Here we had this one. Grid filled and this one, I think. Yeah, 7 left was it. Let's look at the first one. I don't think that's a magenta, the first one. Let me see what I think that is. I think that's a black. Let me look at the middle one. Or let me double check the first one first. Yeah, I think that's a black. We're gonna check the middle one. I still think that's a magenta. The last one. Yeah, that's a magenta. Black, magenta, that's an X-ray. And 7 left. 1, 2, 3, 4, 5, 6, 7. That's an I. And if only marble, yes. So this is our string, if only marble. I don't need to get the last two because there's no need. I have already confirmed that this is the one. So we're going to note down our E here, and we're just going to leave it be. Right now, we're not going to need it. Now we're going to do the first really not fun part, because this is just a bunch of number bullshit. So we're going to get 2 sequences, Alpha Bravo, and a last one, Gamma. Alpha Beta, actually. Can you stop? There we go. Yeah, so what you're going to do is you're going to write down the first number you see here as an alpha, 707. The next number you see, the next digit number, you're going to write as a beta, which is 831. Then an alpha again, and then a beta. And then an alpha, and then a beta, and so on, and so on. And you're going to keep doing this until you're out a lot of numbers. So 423, or 523, 275, 682, I think it was. 682, yep, 340. 966. 154. These are the alpha and beta, respectively. Then, we're going to get gamma. Quite simple. Take the first in A, second in beta, third in A, fourth in beta, and so on. So just switch between going alpha, beta, alpha, beta. So we're going to take 1 from alpha, 1 from beta, 1 from alpha, 1 from beta, and so on. Until we're all out of numbers. 9... Oh, that's not how you do that. 8, 0, 9, 5, 6. So, yep. 9, 5, 7, 3, 3, 8, 0, 9, 5, 6. Okay. This is our little sequence here. And then we're going to follow these 4 quite simple rules. If the difference between the current A and B digit is 5, replace gamma symbol with equals. That does not apply, not apply, not apply, not apply. This one applies. We're going to replace you with an equals. No. No more equal signs. Then we'll look at the second rule. If the current and previous A digit alpha digits match, replace gamma's value with a plus. So basically, is there 2 in a row? Here there's 2 in a row in alpha, so we're going to replace you with a plus. Then we're going to look everywhere else. In beta, is there 2 digits that match? Replace it with a multiplication sign. That does not apply. There's not one where there's 2. If there's current and previous in gamma, replace it with a greater than. 2 greater thans. Alright. So, now we're going to take a look at the number we got here. I'm going to place you down here. We're going to take a look. Is the first and third digit the same? And or is the third and fourth digit the same? If that applies, we have to apply the not equivalent to this. The not being this table down here. So 0 becomes 4, 1 becomes 3, 2 becomes 2, 3 becomes 1, 4 becomes 0. As you can see up here, before doing logic gates, yeah. So, but since that these do not match and these do not match, we don't have to do the not. Yep. Now, we're gonna do something absolutely hilarious. I'm gonna quickly set up this thingamajig, and I'll explain what I'm doing. So we're gonna be doing, because there's 15 things right here, we're gonna be doing 15 table lookups. I know, aren't you excited? This is the fun part. So we're gonna be doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I'm gonna place each gamma in here. Why? Because doing it this way ensures me that when I'm looking at my log, when I inevitably strike on the module, I know where I went wrong. You don't have to make it as neatly organized as this, like Dicey would say. I fully understand that. Do whatever fits you best. I like it when my things are extremely organized, because then I can only blame myself, not my notes. And blaming my notes is not a valid excuse. Okay, so what we're going to do is we're going to look at table 7. Table 7, you're right there. Gullibility. Take the first 2 digits and use the left as the row and the right as the column. Once we have this, we're going to append the result to the sequence and remove the first digit. Now, once we've done this, we move on. But if at any point, at any time, the second and fourth digits match, replace the fourth one with the highest unused digit if you did not apply the 4-bit not before doing this, or the lowest if you did apply the 4-bit not. We did not apply the 4-bit not beforehand if the first and third in that matched, so we're going to apply the biggest. As you can see here, change the newly added digit operand to the smallest number not present if the not was applied, otherwise biggest. So, we're going to change it to the biggest. 4 is not here, so we can use that. If we had the number 4113, the biggest number here would be 2, because 4 is already in use, 3 is already in use, so we have to use 2. Reminder, it's the biggest unused digit. If the digit's already there, you can't add it. Now we just have to do that with a new number. So we take the number we just got, and then we're going to put it down here. And then we're going to run that through table 3. Only 14 times more to go. 0, 0 is a 4. Then we're going to pop you down here. And then we're going to look through 7 again. With 0, 1 being 0. Then we'll look through 4. 4 is a 1, 4. That's a 2. Then we're going to go through 9 with a 4, 4. That is a 4 again. Then we'll look at greater than, which is 4, 0. That's another 0. Then we're going to go through 5. 5 with a 0, 2. That's another 2. Then we're going to go through equals with 2, 4. That is a 0. Uh-oh, we're going to have to apply it with a 3. Because we can't use 4, and 3 was the highest unused. Why? Because the second and fourth digit match. So we do that. Then we look at here, 3, 4, 0. That is another 0. Greater than 0, 2. Could you not? 0, 2 was a 4. Then we're going to go through 8. 8 with 2, 3. That is another 3. Oh, we're almost done. I'm having so much fun right now. Yippee! Now we're going to go through 0. 3, 0 is another 0. Then we're going to go through 9. With a 0, 4. That's a 0. Go through 5. 4, 3 is a 1. Then we're going to go through plus with a 3, 0. That's a 3. Now, you might ask yourself, why did I just waste my time doing this? Well, there's a good explanation. It's to solve the module. Now we're going to copy A and Brav, alpha and beta, down here, and then we're going to add a little dash down here. Now you want to add the last digit. This is called the operand. The operand is the result you got from the tables in this thing. I'm going to explain this because other people might be using this setup that I have. So the output you get from the tables is the thing you get as the last digit. That is called the operand up here. And the operand we need to make into a string here. You could do them one at a time, but I'm telling you, if you do it one at a time, it's... Oh, you're switching tasks constantly, so you can't get a good pace. I do it all at once here, then all at once here, because it's just so much faster. 4402, 402, 304, 330. I can't use words. Okay. I'm going to quickly open a can of Coca-Cola, because I am thirsty. Bear with me here. Hydration. Or should I say dehydration? Then we're going to take this Omicron, I think that's the Greek symbol, and put him down here. And then, using the operand as the operator, or whatever, in here, we're going to do some calculations. I like to start from the bottom to the top, starting with all the zeros. The zeros is just multiplication. So we take alpha times beta. So 1 times 7, that's 7. 9 times 8, 9 times 8, that is 72. We take the last digit, that's a 2. 3 times 5, that is a 15. That is a 0 times 2, which is 0. 1 times 9 is a 9. Those were all the zeros. Then we're just going to take the absolute value of the difference. So just take the absolute difference. So, and that's all the ones. Oh, we only have 1, 1. The difference between these digits is a 1, so the answer is a 1. 2 is add them together. 0 plus 4 is 4. 2 plus 5 is 7. 3 is all the smallest value, or if they're the same, then both the numbers. So smallest value, that's what the minimum thing means. Take the smallest value of these two. 4 is the maximum value. Take the highest value out of the two. So 7, 8. 8 is larger. We're going to take 8. And here we're going to take 3, 9, and 6. Good. Let me quickly just check. I didn't make any mistake. Quickly just glancing over. Yeah, I don't see any mistakes. And now is the last stretch. You can do it, guys. Don't turn off the video. Now we're going to take our key down here, and we're going to plop him down here. Because now, just like in octOS, we're going to be taking the digital root of this. Yeah, you're going to add 7 to each of these digits, because that's our key. And then you're going to be taking the digital root. Quick side note, if you get a number larger than 10 here, I would recommend taking the digital root of your key before doing this. Why? Because let's say I have 24 plus 7 in digital root. 24 plus 7, 24 plus 7, that's going to be a 4. But I could also just do 2 plus 4, which is a 6, and then 6 plus 7. 6 plus 7 being 13, which is a 4. So, to save yourself time adding all these digits, take the digital root of your key first. Because it's so much easier. So, and, okay, so, let's just go. 8 plus 7, that's 6. If you don't know what a digital root is, it's just 1, 2, 3, 4, 5 is equal to 1 plus 2 plus 3 plus 4 plus 5. And then you plop that in here. That gives us 15, which is equal to 1 plus 5, which turns into 6. That's the digital root. Root. I can talk like a human being. Alright. So, now we're going to add, that becomes 10, that becomes 14, so 15, that becomes 11, that becomes... If you ever add 9 to something, it becomes the other digit. So 7 plus 9 is 7. That's just a rule. That's going to be 12 plus 13. That's going to be 4, I think. 7 is 14, 13, 4. Yep. 4, that's going to be 11, so 2, 7, 7, 8. 4 is going to be a 2. Let's just math it up. 7 plus 3, 1, yep. 7 plus 7, yep. 7 plus 4, plus 9, yep. 7 plus 2, 7 plus 5, that's a 3, yes. 7 plus 6, that's a 4. 7 plus 0, yep, that's it. Now we're almost done. Now I'm going to take these, split them into pairs of 3. Once we have our delectable pairs of 3, we're going to take the left 2 digits plus the right digit times 10. So 61 plus 5 times 10. That gives us 111. 27 plus 90. Again, you're always taking the left 2 digits and adding the rightmost digit plus times 10. So 61 plus 50, 27 plus 90, 59 plus 30, and so on. 59 plus 30, 89, 42 plus 70, that's 112, 78 plus 20. We have a lot of things that are over 100. Once you have done this, you wanna, what is it? Subtract 100 if it's over 3, basically just making sure it's not 100. So if it's over 100, subtract it, and add a leading 0 if it's less than 10. And then we're gonna link these sums together into the final number down. Doodaloo-doo. Time to have the most fun you will ever have. Okay. Now we have to apply sequence modification, which is these rules until it's 3 digits long. I'm quickly going to be doing something that's going to make it easier. Because in here, we need to check if it's divisible by 3 based on position, and if it's prime based on position. So, to do that, to make sure I don't have to count, I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the prime one. If there's an exclamation point, the position is prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 is prime, 3 is prime, 5 is prime, 7 is prime. That's why I have them there. And then we need to check if the position's not divisible by 3. Basically just this. Yeah. because it says here, if the last digit is divided by 3, replace all 3, 6, and 9 with 7 on position not divided by 3 or 3 otherwise. The first one does not count when you're replacing it. So, few seconds. Having a drink. That's what I get for going to the gym so early and forgetting to stretch. My legs hurt. Okay. We take the number and make a copy. And then we're going to follow the first rule that applies. Actually, first, I'm going to quickly make an example for each and all of these. So this is going to be the 8. This is going to be the 0. This is going to be the 3. This is going to be the prime, so just 2. And this is going to be the everything else. So I'm going to replace the last digit with that. Because all it cares about is the last digit. If the last digit is an 8, replace all the digits with the sum of that digit and their neighboring digit. If the sum is a 2-digit number, take the rightmost digit. So basically, for this number, take the sum of these numbers. For this number, take the sum of these numbers. For this number, take the sum of these numbers, and so on until you get this. So this is a 2, this is a 3, this is a 9, this is a 16, this is a 4, this is a 8, this is a 2, 2, 9, 7. That's how you do the first one. This is the easiest one of them all. Divide by 10, and if it's if it's more than 3 digits long, replace the last digit with an 8. The best rule of them all. It's also the only rule of them all that makes the sequence shorter, which is why you want as many zeros as possible, because you're gonna be doing these rules like 20 times total, and it's painful. 3. If the last digit is divided by 3, that is true. Replace all 3, 6s, and 9s, so these two, with 7 on positions not divisible by 3, so that one gets replaced by 7, and 0 otherwise. Boom, that's how you do that. 2, if the last is a prime, add prime position digits with the last. Subtract non-prime position digits. Basically, if the position is not prime, subtract the last digit. If the digit is prime, add the last digit. Adding and subtracting 10 until within 10 to take the rightmost digit. So for here, we're going to subtract 2, so this gets 9. Here we add 2. Here we subtract 2. Here we add 2. Here we subtract 2. Here we add 2, subtract 2, add 2, and subtract 2. That's the prime case. And otherwise, just subtract all digits with the last. So, -4, -4, -4, -4, -4, -4. Can you guess what we're going to do in here? Yeah, that's right, -4. Here, -4. Yep, -4, -4. That's how you do each individual rule. And you're going to be doing all of these rules until it's 3 digits long. Have fun. So, starting with an 8. Add them together. Actually, no. I had the answer down here. I did the 8. I'm just really going to check if it's correct. 2, 3, 9, 6, 4, 8, 2, 2, 9, 7. Yep. The last is prime. Yes, it is. Then we're going to add and subtract prime. Here we're going to subtract 7. Here we're going to add 7. Here we're going to add 7, subtract 7, add 7, subtract 7, add 7, subtract 7, subtract 7, subtract 7. Oh, we can shorten the sequence. I love shortening the sequence. Literally the best thing in the world. That's a 5, that's a 1. I'm not going to go through the rules every single time, because if I had to explain every single rule to you, I would be here for an hour. So, yeah, follow the last digit and then see what I'm doing. That's a 6, that is a 1. Hey, 911, that's so funny. 1, that is 5, 2, 1, that's 2. 2 go over there. Yes, that's a 2. And 3. Then we're gonna replace all 3s, 6s, and 9s with 7 and 0s. Prime, subtract 7, add 7, add 7, subtract, add... Oh no, yeah, I had to subtract there. 7, subtract 7. That's gonna be 4. Add 2. Subtract 5. And 0. Yep. Check. Wait. Did I do that wrong? No, please don't tell me I did. Let me... God damn it. Now I'm second downing myself. Oh, hold on. Okay, so it's right up here. Then, yes, that we go down here. Then... Yeah. Yeah, that should be correct. Okay. Don't know what happened there. I'm gonna double check this afterwards, because I am already starting to feel a little bit shaky about this. Should I just start? I'm gonna start over. I can't. I don't trust myself. Really. This module, it's giving me... Yeah. I'm doing the tutorial. I cannot risk fucking up. Yep, same number. 5, 0. That becomes 6, 9, 1, 9, 5, 2. 5, 1, 5, 6, 1, 1, 5. Nine plus 5, 8. That's a 2. 5 plus 8. That's a 3. Yep. That's correct. And we have this. Okay. Now we have the 3 rule. The last is with 3, replace 3, 6, and 9s. That's going to be a 7. That's going to become a 0. Yep. Wait. That number. What's the difference up here? 5 to 3. I have you. 5 and 8. The last digit becomes a 3. Oh, wait. Why is that? Yeah, you become a 3. Huh? What's the mistake here? Oh, that's a 6. That's a 6. That's a 7. That should be a 6, right? No, that should be a 7 because it gets changed to a 7. Yeah, yeah. Okay. Okay, that's it. And then you get changed to 0. You're a 6 because 6, you're there. You get changed to 7, and you should be changed into 0. That's the mistake. I knew I did something wrong. God damn it. I don't know why I do this module. 7, that's 14. 3. Again, that's 3. That's 9. 7. 4. 3. Ah. Thirsty. That's a 7. That's a 0. That's a 7. That is a 7. That is a 7. That is a lot of 7s. 7. That's the prime. 0, 8, 7, 0, 4, 0. I don't trust myself to do mental math. That's a 1, yes. 0, 8. That's right. Zero's also divisible. Right? Am I just... Okay, it is. Oh my god. I hate this. This is the second time I've just glossed over and found a mistake. Wait, that's not the divisible, right? No, that's 3. I thought, no, huh? Wait, subtract 7, yes. Add 7. Oh my god. I don't want to do this module. Okay. Here. U7, yes. U0, yes. U7, 7. You are already 7, U7. Here. Subtract, yes. You have to be a 7. God damn it. That's subtract, yes. That's add, yes. That's subtract. That's subtract. That becomes this, right? Right, please. I think that's right. Oh my god, if this is not right, I'm actually... Okay. That's an 8. 8, 16, so 15, 15, 1, 4, 2, 8. Good, less is still an 8. 2, that's 3. That is 8. That is a 1. That is a 0. That is a 7. That's a 4. That's a 0. That's gonna be... My brain keeps freezing. Wait. Yeah, okay. I'm gonna get through this. 1, 2. That is a 2. 9, 8, 8, 16, 15, 5. 5. Cool thing about the 5 one, you just change it from its number to the 5 inverse. 5 inverse is just add 5 or subtract 5. So, like this. If you find one of these numbers, replace it with its counterpart. Because this will always be the case. You don't have to add or subtract when you're in this scenario. It's just how it is. So if you see 1, replace it with a 6. If you see 6, replace it with a 1. That becomes 6. That becomes 7. That becomes 4. That becomes 3, 0, 0. Very simple rule. Wait. Yeah, 0, 0. Don't know what happened there. It was like copy paste. Then we divide you by 10. Make the last digit an 8. This 0! How could you delete the 0? Oh, 7, 14, 13, 7, 4, 5, 1, 1. That's just subtract all with the last, I think. Yep. So that would be a 2, 6, 3, 4, 0, 8. 8. That's gonna be 9, so 1. That's gonna be 7. That's gonna be a 1. Place them again, so 7, 0, 6, 0. Divide by 10. Do not replace the last digit. I cannot be bothered to recheck this. If I'm wrong somewhere, then that's the tutorial, because I don't care anymore. Okay. First 7 is the first digit. Okay. I got 7. 0 is also on the first one. So 7, 0, and then 6. God damn it. When is the last 6? 340. Yeah. I don't like that I have to submit the last one. Okay, so right after 340. Oh, thank you. This was a painful experience. That took an hour of my life? No. Don't tell me I wasted an hour on that. Fun module. Fun module. Fun module. Anyways, remember to smash that like button, subscribe, hit the notification bell button. I don't know. Don't do this module. Bye.